Okay, guys, so good evening. Now let's start with the today's session. So today we are going to perform a lab task. Okay, so this lab, as I already discussed in our last session, that we are going to do the lab on the L3 VPN, which is Intra-AS L3 VPN. Okay, so let's go and start the lab. So this is going to be our topology. Okay, this is our MPLS core where we have two iOS XR and two iOS XE. One iOS XR as a P device, one iOS XE as a P device, and similarly one iOS XR as PE and another PE is iOS XE. We have two VRFs, red and blue. There are two sites, customer A1, customer A2, which is in the red VRF, and customer B1 and customer B2, which is in the blue VRF. So if you can see on the PE1, there are two customer connected, A1 and B1. Both are having 10.1.1.0 subnet. Okay, both are member of 10.1.1.0. So if you remember from my last session, that what is the reason behind using the MPLS L3 VPN? So the reason behind is that if our customers are having the same IP subnet, same private IP subnet, and we are providing MPLS connectivity, that means to say private network, private cloud kind of stuff. So there, I need to publish their private IPs to the other end. So I cannot do that if multiple customers are using same. So for that kind of scenario, we have L3 VPN, which provides the L3 layer 3 connectivity from one end to the other end, where I will route the multiple customers same network to their remote site. So you can see I have 10110 from customer A1. Similarly, I have 10110 from customer B1. So these are the loopbacks which we can simulate as a LAN traffic. So 100 which is our on A1 side, 100 is on the A2 side. Similarly, 101 is at B1 side, and 101 is at B2 side. So we will perform the lab step by step. I will explain you what all steps you need to perform and what all things you need to take care, what should be done first, what should be do second. And you guys are already having quite a good experience, so you know how to do this, but I'm just trying to highlight you that so that you will do in a systematic manner. So if something goes wrong, see, if everything goes well, it's all good, not a problem. But if something goes wrong, we have to have the step by step guide, so that we can basically see that okay, where is the issue, and we can find it out. Guys, from my experience, I can say L3 VPN is one of the complex kind of configuration which you need to perform in a service provider network, and troubleshooting this is also again more complex. Okay, so you have to have all these steps in your mind, that okay, you are doing this, you are getting this, you are doing this, you are getting this. So you have to have all these things in your mind when you are troubleshooting it. And as per my experience, for performing the troubleshooting, first of all, you need to know the configuration steps. You need to know how we are configuring it, what we are getting out of it. Then only you can do the end to end troubleshooting. Okay, so the same thing I'm going to perform now. So I will perform step by step. I will explain you one by one all these steps. Okay, and then at the end in Q&A, we'll have the questions. Okay, so this is the topology which we are going to refer. So for our first step is setting up IP addresses. My devices are totally blank. I don't have even the IP addresses configured yet. So I'm going to start up from the scratch, because some of you guys have good lot of experience. Some of you, if you are not aware of, like iOS XE is okay. Maybe some of you are not aware of iOS XR. So I'm going to start from the scratch. So let's take this topology as a reference and configure the IP addresses. So let me access the devices. Okay. So we are starting with our customer A1 device. So I'm just now configuring only IP addresses. So I'm creating loopback for the simulating my LAN traffic. Customer B1. I'll make the font bit enlarged so that everyone is able to see. This is B1, which is again 10.1.1 only. This is B2. Here's I'm having my B2. Customer B2. So this is B2, which is 10.1.3. And line side will be 101. This is customer A2. This will be 100, 102. This is PE2. This is 22. Sorry. Okay. Let's move further. This is 6R. This is node PE1. So here is it. Yes. So I'm not configuring the interfaces which is facing towards the customer. I'm just configuring within the cloud only. Then we go 1, 1, 1, 1. Two, 1, 1, 1, 2, dot 1, 1. And they look back. Sure. Okay, so all IPs looks good to me. This is the last one, which is P1. Is cake 00.1. This one. Okay. So guys, step 1 is done. All IP addresses are configured on all the devices. Let me see the further steps. Step 2, configure IGP inside the MPLS core network. So I need to have the IGP connectivity between in my core network. So what I'm going to do, I'm going to run a IGP. So I'm going to run OSPF, which is area 0, inside of my core network. Okay, the MPLS core part only. So let me access the devices. This is PE1. Let me hardcode the router ID. Okay, so what are the interfaces? Gig02, Gig03. as well as the loopback. Done. Now let's access the other devices. P1. One and loopback. Done. Neighborship 1 done between those two because which they are configured. Now this is P2. So this is iOS XE. Okay, now I need PE1 is done. P1 and P2 now. Okay, so P1. Mm-hmm. So I'm getting 1 to 11. I'm not getting 22. So PE2 is pending. So this is again the iOS XE only. Oops, sorry. One, two, 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 two. Okay. So my IGP is end-to-end done. My access. So I'm getting all four. 1, 2, 11, which is PE1, and 22, which is PE2. So my this step is done. So if I'm moving forward, step 3 saying configure LDP inside of the MPLS core network. So I need to configure LDP now between those devices. So let's configure that. MPLS LDP router ID interface is X0002 interface X0003 connect. P1 MPLS MVP show MPLS entity neighbor. So I'm able to form the neighborship between those two as they are configured. P1 P1 is on P2 MPLS IP look like 0. Okay, so my neighborship is done with show MPLS entity neighbor. Now P2 this. Okay, so I'm getting my neighborships done. So my LTP peering is up now. So my LDP is completely formed between inside my MPLS code. So step 4 is configure VRF and assign to the appropriate interfaces. So which devices I'm going to configure the VRF? I've already explained about the VRF in my past sessions. So I'm going to configure on PE1 and PE2. I will configure blue and red VRF and assign to the appropriate towards the customer. What is going to happen after assigning the VRF? So what going to happen is they are going to make the separate routing tables for each and every customer. So as many VRFs I create, that many of dedicated routing tables will be created on the router, so that the prefixes which are received from the customer will be kept into the different routing table, so they will not match up with each other. So same way, if I can see in PE1 I am getting 10110 from customer A1. Similarly, I'm getting 10110 from customer B1 also. So I'm going to get two 10110. So how can I send the traffic towards it? How will I make sure that, okay, but this traffic is for A1 or this traffic is for B1? So for that, I'm going to create the VRF. So let's start with the PE1 itself. So I'm going to create VRF red. So I already explained about the VRF functions. I will assign the router ID in iOS RD value. So in iOS XR we need to assign the RD value under the BGP. So VRF red RD11. So VRF blue RD2 and commit. So as I mentioned last time, RD has to be unique locally on the router. Now need to assign to the interface. So interface gig 0 which is towards customer A1. So VRF red IPv4 address 10.101.10 Why I have not configured IP address earlier? Because as soon as I implement the VRF under the interface, it automatically removes the IP address. Then I need to add it again. So that's why I add it at the end, so that I don't need to add again. Because whatever layer 3 configurations you are going to have on your interface and you implement VRF, it just wipe out all the configurations. So now shut, commit, done. Same way, gate 0001 VRF blue v4 address is again 10.1.1.10, same IP. You can see here also it was 10. Now I'm also configuring the same IP but in different VRFs. Now shut, commit. So if I do show route VRF red, I'm getting 10.1.1.10, which is my IP. And same way, if I do blue, I'm having 10.1.1.10. But if I do show route, I don't have either one of them. I don't even have the 10.1 network. Why? Because now I'm having dedicated routing table, and they are dedicated to those customers only. So now whatever prefix I'm going to learn from those customers will be kept into these routing table instead of. So this is called a global routing table. This is called global routing table, in which I have my MPLS core network. Okay, my global routing. And this is called VRF routing table. Some people say, some vendors have VPN routing table also. So red. So this is specific to particular customer, red customer, and this is specific to the blue customer. Okay. So the same thing I'm going to perform on PE2, but with few command syntax, because this is iOS XR, so command syntax are a bit different. So this is PE2. ARF definition red. I can specify RD local, so I don't need to be unique on the two router. I can use same RD on two different router. Why? Because this is locally significant only. Definition blue RD2 is to 2. Now interface gig 02. VRF forwarding red. Oops. I need to enable these VRFs for IPv4 also. Red, and this one IPv4. VRF definition. Blue, and this one IPv4. Gigs 2. VRF forwarding red. Gigs 03. VRF forwarding blue. So if I do same thing here, show IP route, this is global routing. So I cannot find those 10.1.2 and 10.1.3 here. Why? Because they are VRF prefixes. So if I need to do show IP route VRF red, I can see 10.1.2. And if I do show IP route VRF blue, I can see 10.1.3. So they are now they are separate. They have dedicated routing tables for their customers. So now whatever we are going to do now, it's all based on the basic main agenda is to make those VRFs, the VPNs, to communicate with each other. So let's see the next step which we have. So this is done. Step 5 is configure PECE routing protocol for VRF red. Okay, so let's configure. So we are going to concentrate on VRF red first of all. Okay, then we'll move into the blue one. Otherwise, steps will be messed up. I want to show you clearly one by one step for one VPN setup. Okay, so that it will be crystal clear in your mind. So I'm going to perform the routing between PECE for red customer. So first of all, I'm going to perform between A1 and PE1. So I'm going to use EIGRP for customer red. Okay. So this is A1. So customer side, no special configuration, nothing. Is just a common EIGRP because customer has nothing to do with your MPLS, with your VPN, all these things. So it's just a simple EIGRP, and I'm publishing all my networks because it's kind of a branch office which is publishing everything towards the head office. So done EIGRP. Now I'm going to configure EIGRP on PE1, which may be quite bit different because we are going to run for VRF, for a dedicated VRF, not a global EIGRP. So if I just straightforward configure, it will be a global EIGRP. So router EIGRP1 VRF red. I need to specify that this is for the VRF. Then address runway IPv4 VRF red. So autonomous system number. So here I need to specify AS number. Okay, so this AS number doesn't matter. When we configure under VRF, it should be associated with the appropriate autonomous system. So okay, EIGRP1 VRF red, pressing IPv4 autonomous system 1. Specify just one network which is under that VRF. So that is my gig 00 interface. So interface IPv4 no need to specify guys. Let it commit first. Show run router ARP. Okay, now it looks good to me. IPv4 now my interface. Just one interface, guys. Remember, only publish the interface which is under the VRF. So show run router EIGRP1. Yeah, now it looks good. Show EIGRP VRF red neighbor. So if I do show EIGRP neighbor, it won't show me anything. I need to check under the VRF. So I have my neighborship up. If I do show show route VRF red, I can get 100, which is learning from customer A1. So same thing I'm going to perform here. I'm going to use EIGRP only for customer red only. For customer blue, we'll use different routing protocol. So now let me go to PE2. Unit test. So let me configure A2 first. A2. A2 yet. So B1, B2. I was at it. Okay, so simple EIGRP. I'm publishing on the networks. That's all. Now on PE2, EIGRP under VRF, but this is iOS XE, so command line says EIGRP1. Here we don't specify VRF here. We will specify address from the IPv4 VRF red here. Okay, and then same autonomous system number. Personally, 1.1.2.0. IPv4 VRF red autonomous system number. Okay, so EIGRP was up because network command they are already taken. So let me show you the config. So this is the config. So again, this AS number have no significance. This is the AS number which actually we are going to use. So my network which is under the VRF, now neighborship is up. I can check show IP route VRF red and I am getting 100, 100, 102 from the EIGRP. Okay, from my customer side. Why is 24? Should be 32. Check. Okay, I configured by mistake as 24. That's good. Now it's 32. Okay. So I have my VRF PECE routing running for red VRF. Okay. So let's see the next step. Configure MP-BGP session between PE1 and PE2. So as I already mentioned in my last session that for exchanging the VRF route, we need a protocol called MP-BGP. So we are going to run MP-BGP between PE1 and PE2. So let's configure that. I guess all other guys can hear me. Smriti Bhushan. Are you guys able to hear me properly? Is there any voice disturbance? Okay, so Smriti, you can check at your end, it may be from your side. Okay, so router BGP 100. Yes, address family IPv4 unicast address family VPN v4 unicast neighbor 22 22 22 22 remote AS100 because I'm getting in Intra-AS. I'm making neighborship with loopback, so Update source look like 0. Enable for address only IPv4. Unicast. As well as for address only IPv4 unicast. So let's publish. No. So commit. Guys, please be on mute. I'm getting some voice from someone's. Please be yourself mute, otherwise it will create voice disturbance. Okay, so BGP is good here. Now let me go to PE2. Okay, BGP. Very counting is 100. Update source, look like 0. Send VPN v4. So IPv4 is up. Now let me establish VPN v4 also. Activate. Send community. Send community. Why? Because the value route target which I'm going to assign now, it's considered as a community in BGP. So for exchanging that, I have to have the send community enabled. So I didn't enable, I guess, on PE1. Let me see the config. Show run router BGP. Yeah, I didn't enable it. So router BGP 100. And this one before. First, let me add it later. So, import the changes. Now my BGP should be up for both. So show BGP all summary. Let's go VPN v4 unicast summary. So my neighborship is up, okay, but I'm not receiving any prefix. Why? Because I haven't advertised anything. So same here, show IP-BGP VPN v4 all summary. So neighborship is up, but no prefix is received because not advertised. Okay, so my MP-BGP session between both the PEs is up. Let me go to the other step. This is done. Step 7, redistribute CE routes to MP-BGP on appropriate PEs. So I need to redistribute because see, just put your focus on this side that you are learning the routes from customer A1 using the EIGRP routing protocol, right? We are learning the customer route using EIGRP, but from one PE to other PE, I am having MP-BGP. So how can MP-BGP carry EIGRP routes? I need to redistribute EIGRP into MP-BGP. See, don't go into the data plane side. Right now, we are just talking about the control plane. It's all just control plane we are setting up. So for taking the route, I need to take the route from EIGRP, put into the BGP, send to the other side, so that the other side should be able to learn that. So if I go on PE2 right now, and I do show IP BGP VPN v4 all, I'm not learning any route. Why? Because he's not advertising anything. So now let's go on PE1 and do this redistribution. So I'm learning EIGRP route. If I do show IP route, show route VRF red I'm getting this route through EIGRP. I need to put this EIGRP into BGP so that it can take further. Okay, so this is your EIGRP until this point, and here you have your kind of a tunnel, which is MP-BGP tunnel. So you need to put this EIGRP into tunnel so that BGP can take it forward towards the remote side. Okay, so BGP will take it all the way till this point. So I need to put my customer route into my MP-BGP tunnel. So how can I do this? This needs to be done using my redistribution. So let's do that. PE1. I'm going under my MP-BGP and going under specific VRF red. Sorry, VRF red address from IP for unicast. Here I will redistribute EIGRP 1. Done. Let me show you the config. Show run router BGP. So under VRF red, under address family IPv4, I redistributed EIGRP. Now let's go on the remote side and see whether I'm learning the routes now. So I'm not able to learn the route. What may be the reason? So the reason is I haven't configured the route targets yet. So yesterday is in the last session, sorry, I told you that if you want specific routes from VRF to the VRF, you need to export route from this side and import route here. Similar way, export route from here, import route here. Okay, so we need to specify values, okay, which we are going to use as route target. Whatever we are exporting here, we need to import on the other side, and whatever we are exporting from the other side, need to import it on this side. So let's do that. PE1. So I need to go under VRF red, address from the IPv4. I'm exporting route target as 100 is to 100. Okay, it is altogether different from RD value. So 100 is to 100. This is what I'm exporting. So on the other side, I need to import same value. Okay, let me access the other side. This is PE2. So I need to import this on this side. So I'm going under VRF definition red route target import 100 is to 100. So I exported 100 from here, imported 100 here. Now vice versa, I will do route target export 200 from here. I'm exporting 200 and I need to import here this. So import route target 200. So whatever I am exporting from one side needs to be imported on the other side. Same way, whatever exported from the other side needs to be imported on this side. So let's commit. Done. And for making sure, just clear BGP once. Show IP BGP VPN v4 all. So see, I'm learning 100 now. Earlier I was not getting any route, and now I'm getting 100 So now what is happening, guys? Understand very carefully. I'm learning the prefixes through EIGRP until PE1. Now I have my MP-BGP tunnel established. Okay, so prefix will come in. I put into this tunnel using EIGRP. Then I add a RT value on it, route target value, whatever I am exporting. So using MP-BGP, it will take it forward to the remote side. Now on the remote side, he needs to import that. So whatever I am exporting, I am importing same RT value here in VRF red. So it will automatically put into VRF red. It will not go into blue. So this is how I am making the segregation, that which VRF route is coming and I need to put into which VRF. So red route is coming, I need to put into the red. So whatever I am exporting from here in red, I need to import same here into the red. Same thing I'm going to perform for the blue as well. Okay, so let's check this thing. If I go on PE2, oops, sorry. So this is under BGP now. Okay, so now what is happening, guys? I got my route from here to here, EIGRP. Here to here, it's BGP. I'm learning route using BGP. But what is between them? What is between CE and PE? It's again EIGRP. So what I need to do? I need to put now this BGP into EIGRP again. Okay, so this is a mutual relation, guys. First EIGRP get into BGP, go to the other side. Now BGP needs to go back into EIGRP to reach to the customer. So if I see, if I go on customer side, which is A2, is A2, yeah, here it is. So if I go on the customer side and do show IP route, I'm not learning anything. Why? Because I don't know until PE point. Until PE I'm having through BGP. Now BGP needs to get into EIGRP, then only customer will get that. So I'm going on PE2 now and going into EIGRP and redistribute BGP 100. So we know that EIGRP have 5 metrics, so I need to specify the seed value. Now I put my BGP into EIGRP. Now as between PE2 and A2 is having the EIGRP, he will get that route. Okay, so let's go on to the A2 now and check. I'm getting 100 using EIGRP. Okay, so guys, you need to keep this thing in mind. From A1 to PE1, EIGRP. From PE1 to PE2, it's BGP. Then from PE2 to A2, again EIGRP. So EIGRP get into BGP, go to the other, all the way to the other end, then BGP again go back into the EIGRP and go to the customer side. Now this is one way direction, A1 to A2. Now need to go to the reverse side also. A2 also needs to go to the remote side. Okay, so how will I do? Now this EIGRP, I need to use this EIGRP, and this is my BGP tunnel. So I need to put this EIGRP now into BGP so that it can take it to the remote side. So let's verify this first of all. If I go on PE1 and I do show BGP VPN v4 unicast all, so I'm not getting 102. Why? Because it is not yet into BGP. It is only till PE2. To get extend it to the PE1, I need to put that EIGRP into BGP. So let's do this. Go to PE2, go into BGP, go under VRF red and redistribute EIGRP. Well, done. Now let's come here and check. See, 102 is now here. Earlier it was until this, until BGP, so sorry, until EIGRP. So as soon as you put EIGRP into BGP, it's sent to the remote side. Now he is having 102. Now what I need to do now? I'm getting my 102 until this point. So this is come to EIGRP. EIGRP put into BGP, then come to this side. Now BGP back to EIGRP so that it can receive to the customer A1. So let me show you. If I go to customer A1, So he don't know anything. Why? Because in EIGRP it is nothing. It's only till PE1 which is in the BGP. Now need to get back BGP into EIGRP. So let's go to PE1. Router EIGRP1 red and something I think before. Redistribute BGP 100 commit show run router EIGRP. So you can see BGP is redistributed under IPv4. Now let's go on A1 and check. Here's my A1. Yeah, I'm getting 100 now using EIGRP. Okay, so you have to understand the control plane first of all. So control plane, what he's saying, A1 route coming to PE1 using EIGRP under VRF. That EIGRP, there is a tunnel established between PE1 and PE2, which is MP-BGP tunnel. That EIGRP sits into MP-BGP tunnel, go all the way to remote side using route target, as I already mentioned. And then this MP-BGP routes get into VRF, red, EIGRP, and go to the remote side. So same thing is happening in the reverse direction also. So this is mutual relation. Now both the customers are having each other's route. So if I go on customer A1, I'm having 100 and if I go to customer A2, I'm having 100 So now let's check the reachability. Then I will show you how data plane is taking in place. So ping 100 source 100 I can reach. Customer to customer reachability is there. Now I want to show you something. Trace route 100 source 100 So it went to PE1, which is 10.1.1.10. Then it go to towards whatever the next hop into my MPLS cloud. But see, I can see two labels here. Okay, I can see here two labels. So this is my LDP label, which is for transport, and this is my service label, which is assigned by MP-BGP. How I know this is this is service label and this is transport label? Why? Because you can see on the next hop I cannot see 18. Why? Because it get popped. But service label will not get popped. It will go all the way until the last the PE. So I'm getting 22 until the next row, but I'm not getting 18. That means to say 18 is getting popped. So that's why 18 is my transport label and 22 is my service label. So what is happening at the back end is traffic will come in as a IP packet. Now I'm talking about data plane. Okay, earlier it was control plane. So just a second. Now IP packet is coming. Okay, this is purely IP packet. Now on this point, as it's part of VRF and MP-BGP, so your IP packet encapsulated, not I will say encapsulated, it will add one label, one additional field that is called MP-BGP header. So this is MP-BGP header where I have what? The remote PE information where the neighborship is getting terminated, my service label which is getting assigned, which is 22 in our case, okay, and the route target. Now I need to take this IP plus MP-BGP to the remote side. For taking it remote side, I add one more label, which is your LDP MPLS label, which is assigning a label of 18. Okay, so this packet will send 18 to this hope. Okay, now he has nothing to do with this. He has nothing to do with this. He will see just 18. Okay, 18, remove 18, pop and send it to the remote side. When it reaches to the PE, then he says pop, okay, remove this. No need to do the label lookup further. I will look into the MP-BGP. MP-BGP says, okay, this is the route target. Let me see where I am importing this route target. I am importing in VRF red. Let's put that into the VRF red and send to the customer side. So this is how the data plane operation takes place. Okay, control plane operation, I already explained you how the EIGRP and BGP is communicating with each other the same way. How the data plane is taking place, this is how. Okay, so this is your end-to-end control plane and data plane. Now let's go and set up the blue VPN also. Now this will is not going to take much time. Why? Because my MP-BGP and everything is already in place. Just I need to set up new things for the blue. So what I'm going to use in blue PECE routing protocol, I'm going to use OSPF. Okay, because this is one of the widely used. So I'm going on customer B1 and running OSPF 101. I'm just advertising all my networks. And area 0. Okay, so now in PE, OSPF needs to configure in different way. So OSPF 1 I'm already using. I cannot use OSPF 1. So if I show you, show run router OSPF 101. Oh, sorry, I mistakenly configured 101. So 101 I'm already using. I cannot use 101 for PECE. Okay, I need to use a different process of OSPF. So I'm going to use router OSPF 102 because you guys know we don't need that process ID needs to be same on both the sides. So here I'm learning on customer side it's 101. I can use 102. It's not a big deal for me, but I need to specify that is VRF red. Okay, and I need to specify a router ID for this. I'm saying 102.102.102.102. Okay, because router ID I can use any one of it. Area 0 interface. This is gig 001. That's all. Commit. Okay, let's come out. Show run router OSPF. So this is the OSPF 102 configuration. Oh, okay, Puran. Thank you. Sorry, guys. I did wrong. I used red again. It's blue. Thanks, Puran, to remind me. Show run router OSPF. So it's removed. Now router OSPF 102 VRF blue. Okay. Router ID area 0. Commit. Now show run router OSPF. So this is my OSPF for blue VRF. Now it should come up. So show OSPF VRF blue neighbor. So my neighborship is up with customer. If I do show route VRF blue, I'm getting OSPF 101 route. Now let's do the same thing on the PE2 also. So this is PE2. Router OSPF 102 VRF blue router ID 02 I'm using. network 10.1.3.0. Let's go to the B2 customer. B2, it is again normal OSPF and all the networks. So neighborship should be up by the time. We are at blue. Show IP interface brief. Then we are at blue 10.1.3.2. Okay, then show IP OSPF meter. It's still going on. Okay, it's stuck in at start stage. Done. So neighborship is up. So if I do show IP route VRF blue, getting 101.101.101.2. There is 101.101.101.1. So PECE routing done. No need to explain again. Need to put into the MP-BGP mutually. But before that, I need to do the route targets. So let's go to PE1. VRF blue. Address IPv4. Here, export route target is 101 colon 101 and import route target 102. So I can use same also, guys. Okay, so let me show you same. I can import export same value, and I need to do the same thing on the remote side also then. So PE2, so on this side also we have definition blue route target. I can use both, means import and export if I'm using same value. Done. Now let's put routes into the P1 is this side, PE2 is this side. So let's redistribute the routes. Go under router BGP 100, address running IPv4 VRF. Sorry, this is ISXR. VRF blue, address running IPv4 unicast, and redistribute OSPF 102. Let's cross check the OSPF is sent. Yeah, it's 102 for blue. Now I should get routes into BGP on this side. So show IP BGP VPN v4 or so I'm getting 101.1.0.1.1. So I'm getting all the way this side. This is 1.1, which is VRF red. I'm getting 101 in VRF blue. So it automatically segregated. How it gets segregated? With the help of the route targets which I am using. Okay, it got segregated. Now again MP-BGP needs to land into the VRF blue. So I'm using OSPF 102. So router OSPF 102. Redistribute BGP 100. Done. So customer B2 this side, this B1 route should come now. Where is B2? Here it is. Show IP route. So I'm getting 101.101.101.1, which is B1 route. So one side is done. Now need to set up control plane on the reverse side. So go to PE2 first of all. PE2 going to BGP. This one here B for PRF. Blue redistribute OSPF 102. Now that 100.1 should come on PE1 until PE1, not at the customer side. So let's go on PE1 and check. Show BGP VPN v4 unicast all. So if I see in VRF blue, I'm getting 101.101.2, which is B2. So this has come all the way to till PE1. Now the BGP needs to put that route into the OSPF. So router OSPF 102, yeah, blue, we distribute BGP 100, comment. Done. Now let's now B1 should get that. So this B1. So I'm getting 101.101.101.2. So let's try. So I have the reachability. Boom, done. So let's do the trace route. Source. Done. 18 label. Service label which is assigned is 24. Okay. So the same data plane operation is happening here also. Now, if you notice that if I ping 101.101.101.2 using source 101.101.1, I can ping. But if I'm using without source, I can ping because I'm publishing this network also. Okay. If I don't publish, because if I go on the middle router, okay, let me show you. If I go, let's say on P1, those router have no idea about these prefixes. Show route. They don't know anything about that 10.11, 10.12, 10.13, 101, 100. They don't have any. Why? Because they have nothing to do that. Those forwarding router, those P router are actually basically doing the forwarding job, which is based on the labels, not based on the IPs. So that's why MPLS is also considered as BGP free core also. If we are using MPLS, we don't need to have the end-to-end full mesh BGP in my core. Why? Because the forwarding is not on IP, it's on label. BGP provide IP reachability. I doing label forwarding. I don't need the end-to-end IP reachability. I don't need my customer routes to be available in my service provider core. So it makes the BGP free core by the use of MPLS. So this is all about, guys, for intra-AS L3 VPN. Now time for Q&A. Post your questions, guys. Hope you like the practical session. Now questions, guys. Any questions, guys, which you are having, or all good? Okay, good, Puran. Other guys, any question? all the sessions are available online, Smriti. You can access it. Okay, I'll check. Any question, guys? All good. No question. Okay, so I'm considering no more questions. So it's good. You guys understand. You guys should do practice, practice, practice. And anytime, if you feel any question, any confusion, you can come back to me. Okay. So hope you like this session. Now see you in the next session. Okay, guys. Bye.